Lesson 6-5, multiplying and dividing decimals. And in this lesson, you learn to multiply and divide decimals. Why is it important? Because you will divide decimals when comparing the costs of different sized items. Let's take a look at this activity. You can multiply decimals in the same way that you multiply whole numbers. Look for a pattern in the products below to help you write the rule for placing the decimal point in the product. Use a calculator to find each product. So if you multiply 15.6 times 38 with your calculator, it'll give you 592.8. If you multiply 15.6 times 3.8 this time instead of 38, end up with 59.28. If you multiply 15.6 times 0.38, that'll be 5.928. And if you multiply 5.6 times 0.038, you guessed it, it would be 0.5928. So describe the pattern in the factors of the problems above. Okay, so the pattern of the factors, you have 3.8, which became 3.8. So you move the decimal place to the left, okay, once, right here, and that's the reason why you got 3.8. And then you move it again once, that's the reason why you got 0.38. And you moved it again one time, and that's why you got 0.038. Okay, describe the pattern of the product. As you move the decimal place to one space to the left, the decimal place on the product move one space to the left as well. So 592.8 became 528 because that will move one space to the left. Okay, 59.28 became 5.928, and 5.928 became 0.5928. Okay, so in this case, if we want to predict what would be 15.6 times 0.0038, you would notice that, okay, the answer would be, okay, the answer would be okay, 0.5928. The explanation for this is that we moved the decimal one space to the left right here. That means we need to move this one space to the left, and that's the reason why we are going to get 0.05928. So write a rule for placing a decimal point in a product of two decimals, and this is where we are right now. Before we do that, when you multiply decimals, it is helpful for you to it is helpful to use estimation to verify the placement of a decimal point. Okay, so when you're writing a rule for placing the decimal point in the product of two decimals, you're basically saying that if you count the number of decimal places in each of these problems, if you look at the factor 5.6, it has one decimal point. 38 has none, so you have one decimal point as the product. In the second problem, you have one decimal point and another decimal point. If you add those two decimal point, the one decimal place, or one digit after the decimal point, one digit after the decimal point, so you have two digits after the decimal point, 1 plus 1. This is one digit after the decimal point, two digits after the decimal point, so you end up with three digits. Okay, one digit after the decimal point, three digits after the decimal point, you end up with four digits, 1, 2, 3, 4. So you're adding the number of digits that are after the decimal point, and that would be a rule. Okay, so when you're multiplying factors, you simply add the number of decimal points, add the digits that are after the decimal point, and that's where you will know where to put the decimal point. So in this case, we can find out the placement of our decimal point when we solve c equals 3.9 times 8.2. Go back to our basics. Let's estimate 3.9 to become 4 and 8.2 to become 8. Our answer should be close to 32. So let's do this vertically. 3.9 times 8.2. And you know that there is one decimal point in 3.9 and one decimal point one decimal place in 3.9 and one decimal place in 8.2. Okay, and if we multiply 3.9 times 8.2, okay, 2 times 9 will give you 18, carry 1, 6, it will give you 78. Okay, so we are disregarding the decimal places as of this time until we are done with multiplication. So we're basically multiplying these two normally as if they're whole numbers. And if we multiply now 8 times 9, we add a 0 first to this one. So 8 times 9 is 72, carry 7. 8 times 3 is 24, carry 7. That'll give us 312. Bring down the 0 right there. Or add a 0 right there. Okay, and if we add them all up, we end up with 31.98 because we simply added one decimal place plus one decimal place will give us two decimal places. And C equals 31.98, and if we compare the estimate to our answer, they are very close. Okay, let's take a look at letter B. You have x equals negative 6.302 times 0.81. Okay, let's estimate first. Okay, before we do that, we know that a negative times a positive will always be a negative. So our estimate will have a negative answer. So negative 6.302 is close to negative 6 and 0.81 is close to 1. Our answer should be close to negative 6. We know that our product will be negative because we are multiplying a negative by a positive. So let's do this vertically. Okay, and we know that there are 3 decimal places in negative 6.02 and there are 2 decimal places in positive 0.81. And we do our multiplication for this, okay, and we end up with negative 5.10462. Why are there 5 decimal places? Because we are simply adding the 3 decimal places plus 2 decimal places will give us 5 decimal places, and we count 1, 2, 3, 4. 1, and we use it in blue so it will disappear. 1, 2, 3, 4, 5 decimal places. And that's why you end up with negative 5.1062. And if you notice, our estimate is close to our exact answer. And we are good to go, where x is equal to negative 5.10462. Okay? So all the properties that were true for multiplication of integers are also true for multiplication of rationals. The properties of rationals are summarized in the following chart. Before we do the following chart, okay, the secret word for this lesson will be rules. Again, the secret word for this lesson will be rules. Okay, so let's go back. Properties of multiplication using the commutative property of multiplication. Remember, when you hear the word commutative, okay, as a review, it means move. Okay, so the numbers have been moved around, okay, but the product does not change. Okay, so it simply says that for all rational numbers x and y, x times y is equal to y times x. And here are examples. Negative 5 times negative 7 is equal to negative 7 times negative 5. We're moving the numbers around and the product does not change. 0.6 times 1.5 is the same as 1.5 times 0.6. And 5/6 times 8/9 is the same as 8/9 times 5 over 6. In the associative property of multiplication, the root word that we need to talk about is associate or group. So when you think about the associative property of multiplication, we are grouping numbers. Okay, in the commutative property, the order of the numbers change. Okay, from 0.6 times 1.5, for example, it becomes 1.5 equals 0.6. So you notice that the order of the numbers change. In the associative property, it does not. So for all rational numbers x, y, and z, per the quantity x times y, close quantity times z, is equal to x times the quantity y times z. And if you notice in the associative property, the order of the numbers did not change. X, Y, Z remains X, Y, Z. And here are examples. negative 6 times 0.5 in parentheses times 8 is equal to negative 6 times parentheses 5.8. Okay? In the same manner, quantity 0.3 times 4, close quantity times 5.7 is equal to 0.3 times the quantity 4 times 5.7. And lastly, the quantity negative 1/3 times 9 over 10, close quantity times 2 over 5, is the same as negative 1/3 times the quantity 9/10 times 2/5. And if you notice again, the order of the numbers did not change. In the identity property, it simply states this, that if you multiply a number by 1, okay, the number will be the same or it will be identical, and that's the reason why it's called the identity property. Okay, and here are examples of it. Negative 8 times 0.1, sorry, negative 8 times 1, 1 times 1/4, 1.3 times 1 will give you the same, okay, as one of the factors. So in the inverse property, we learned this too. For every rational number x over y, where x, y is not equal to 0, there is a unique number y over x, such as x over y times y over x equals 1. This is simply the multiplicative inverse property, or property of reciprocals. Okay? Examples given: 6 times 1 over 6 is equal to 1. Negative 5 over 12 times negative 12 over 5 is equal to 1. 0.7 times 1 over 0.7 will give you 1 as well. So in the inverse property, the multiplicative inverse property, or the property of reciprocals, the product of two numbers is always equal to 1. Okay, so to divide a decimal by a decimal, okay, to divide by a decimal, think of the division as a fraction and write the divisor or denominator as a whole number. For example, let's consider 50 divided by 0.26. Think of it as 50 over 0.26. Okay, and we have 50 right here. 50 divided by 0.26, okay, will be the same as 50 over 0.26, okay, and multiplied it by 100 over 100, which is also equal to 1. It will be 5,000 over 26 to get rid of our decimal. Okay, since 101 over 100 is equal to 1, the value of the fraction is unchanged. This becomes a division problem involving whole numbers. Okay, so 50 over 0.26, okay, will be the same as 50 divided by 0.26, okay, and then we multiply both the numerator and the denominator by 100 to make your divisor a whole number, okay, just like what we did here, and it will become 5,000 divided by 26, just like this one. Okay, so we divide normally. How many 26s go into 50? We know that there is one 26 that go into 50. So 50, 1 times 26 will give us 26. Subtract 50 minus 26, that would give us, okay, 24. Okay, and bring down the 0 right there. It's not really lined up, but that's okay. So now we have how many 26 is going to 240. That would be equal to 9. That would be equal to 9 times 26 will give us 234. Subtract those two numbers. Okay, will give us 60. Bring down another 0. And how many 26 is going to 60? That would be 2. And that would 26 times 2 will give us 52. Okay, and then subtract that would give us 8. Okay, and bring down that 0, so you end up with 80. Our next answer would be after the decimal. So to how many 26 is going to 80? That would be 3. 3 times 26 will give us 78. Subtract that will give us 2. Bring down another 0 right there. And how many 26 is going to 20? Okay, that would be 0. Okay, we stop there Why? Because we can round it to the nearest tenth. The quotient is 192.3. Okay, so we can estimate this. Well, not really estimate it, but we can round the quotient to the nearest tenth, and that would be the answer. So 50 over 0.26 is approximately 192.3. Okay, let's take a look at example number 2. In example number 2, you're asked to solve y equals 42 divided by 0.8. Let's estimate again. 42 divided by -1, which will give us -42. So our answer should be close to -42. Okay, and let's use division. 42 divided by 0.8. Again, from what we know, we need to make our divisor into a whole number. So this becomes 420 divided by 8. We simply move the decimal point one space to the right, one space to the right, and thus we have 420 divided by 8. And if you divide that using our traditional method, we end up with 52.2. Or the lazy method would be to use a calculator. Okay, well, in this case, it's not asking you to, so we're good to go there. So y equals -52.2, and comparing it to the estimate, it's close enough. Okay? Example number 3. Decimals are used every day when people work with money. So in Columbus, Ohio, our teachers can make use of Regarding Art, a warehouse that recycles materials for use by artists. Membership in the Regarding Art costs Columbus Pacific Schools $500 a year, a cost of about $3.49 for each art teacher. How many art teachers are there in this school system? Okay, so we want to find out 500 divided by 3.49, and we estimate 500 divided by 4, so our answer should be close to 125. Okay, and we make this into our division problem, where 500 goes into our house and 3.49 goes out, and we divide. Okay, 500 divided by 3.49, we make 3.49 into a whole number. Okay, so we have there, we move it there, and this becomes 500 is moved again twice, so our decimal goes up there. Okay, so we multiply this by 100, multiply this by 100, or simply move the decimal place 2 spaces to the right. So the decimal place is there, and we divide normally. How many 349 is going to 500? That would be 1. Okay, subtract that, end up with 151, bring down that 0. How many 1500s? 349 is going to 1510. That would be 4, and the product is 1396. Subtract that, you end up with 114, bring down another 0. How many 349 is going to 1140? That would be 3. Multiply that by 349, 1047. Again, we subtract that, end up with 993, bring down the last 0 right there. Okay, and how many 349 is going to 933? That would be 2, which would have a product of 698. Okay, so we have 698, and subtract that, we end up with 232. Okay, so after this, we stop our division because it's just asking how many art teachers are there in the school system. So we need to round to the nearest ones place, and in order to round to the nearest ones place, we only have to divide to the tens place. So there are 143 or 144 art teachers in the system. If you notice, this rounds to 143, but we chose 144 simply because there's no such thing as 0.2 of an art teacher. So we round up. So 144 art teachers in the system. Okay, and if we check our answer to our estimate, that's close enough, and we know that it's right. Okay, last example, evaluate expressions involving division of decimals in the same way you evaluate algebraic expressions. So let's evaluate 6m over n. Again, the word evaluate means to substitute and to simplify when m is equal to 0.5 and n is equal to negative 3.2. First, we substitute the value of m and n, which is 0.5 and negative 3.2. We know for a fact that when you have a positive divided by a negative, our quotient would be a negative. So you know right away this is negative. Okay? So 6 times 0.5 is 3 divided by negative 3.2. Okay? And using a calculator, that would be negative 0.9375. So the value of the expression, okay, is negative 0.9375. Okay? And that's the end of our lesson. Thank you for watching.